Okay, so what we're going to do here is look at some optimization tools and some kind of the philosophy of what you can use inside the class. So for the various assignments. So we give you a lot of freedom, right? So you can do whatever you want. You can start coding everything in assembly if you want. You can code in Ruby on Rails if you are interested in that. You can do whatever you want. You can even use general purpose optimization tools if you want, and it may be a good idea in some of these assignments. Okay, so you don't need to reinvent the wheel. You can if you want. Okay, so once again, this class is about giving you as much freedom as you can. Okay, so if you use a general optimization tools, there will be a number of advantages. They are generally very designed so that you can very quickly design these models, okay, and get quick solution. They are going to be generally efficient in the kinds of technology that they are implementing. That doesn't mean that your model is going to run fast, because your model may be terrible, okay, or the problem is so hard that no model is very, very good, okay. But typically these tools include years of research, and they spend a lot of time optimizing the algorithm that they are providing, okay. Now in the disadvantage of using these tools is that you will have to learn them, and sometimes learning them is not so easy, okay. There may be limitation of what they are allowing you to do, and how you can extend them if you need to have more capabilities. They are always slower than a dedicated algorithm if you would spend just the same amount of energy to solve a particular problem, okay. Now in practice that may not be cost effective, right? So you developing the same kind of quality as this system may take you much longer than just using them, but you can always find a way to do better, okay, and just recoding some of the stuff and specializing it, for instance, okay. But this is a trade-off that you need to deal with. And then they may sometimes appear to do strange things. Most of the systems these days are using randomization. They may not even give you the same solution if you run them twice in a row. So, and it's not always, they will do all kinds of transformations as well. So it may be that you have a good formulation or a bad formulation. You won't see a difference because the systems are clever enough to actually reformulate the problem. They recognize that you had a bad model and they can reformulate it. So these things, there are a lot of things that you need to take into account when you use various tools. Okay, so the type of tools that you can use are CP solver, MIP solvers, local search solvers. There are many of them. Okay, so one of the things that in this class we won't do is recommend a particular set of tools. We give you a list. You can choose from that list, for instance. Okay, there are other solvers that are not mentioned in the list. We are not trying to be exhaustive. Okay, some of them are open source. You can use them all. You can use them, look at the code if you want. Some of them are free for non-commercial use, okay, or some of them are free for students, okay. So once again, for some of them you will need an account in a university to be able to solve them, okay. So you will have to find the right tools for the right circumstances in which you are working on. But there are a lot of tools that are available, and you have to take them into account. Okay, so let me give you an example of the kind of stuff that you want to see. You may want to try out, and then you will want to see if the solver is supporting things like this. So this is a very the Queen's example that we saw many times, and you had a lot of these binary constraints, disequalities between the various variables. Okay, you may say, oh, but this is like all different, so I can reformulate that as a set of all different constraints. And maybe your system is going to support these two formulations, or maybe not. Okay, so but you may want to try these two models and see how they behave. Okay, so in a sense, if your solver doesn't support this, okay, then you may decide to recode all different yourself. Okay, this is what I'm mentioning there. Or you can say you can look for a CP solver which is actually supporting all different. Most of the CP solver these days would. Okay, so let me give you an example of the second option here. So this is, the N-Queen's problem in the Comet programming languages and system. Okay, so this is the first model. It's very close to the kind of models that we have used inside the slides. So you can state that model that way. If you want to change it to the all different formulation, you just remove these constraints and replace them by those, and you can test these two models. Okay, so what this is showing you is that different tools will actually have different functionalities, but they will allow you to very rapidly prototype different kinds of solution. Okay, so when you see the leaderboards, okay, in most of the assignments, they are typically implemented using dedicated algorithm. They are not using black box solvers in general. But that doesn't mean that you can't get close to this solution using general purpose solvers. In general, you can. Okay. We don't recommend any solver technology in the class, as I told you before. Okay, so we don't, so one of the things that this class is trying to communicate to you is that different problems will be amenable to different kinds of solution, and some of them may be more appropriate for different kinds of problems. Okay, so so you can try all the various technology and all the various solvers that you want, and all the different techniques, or you can implement all the various techniques on every one of the problems. Okay, we want. When the class is running, we won't basically answer specific questions on all the solvers. First, we don't know them all, okay? And then this is something that for you to actually figure out, okay? Obviously, inside the forum and so on, you can ask questions, you can get a recommendation for your friends and so on, and that's completely fine. Just don't expect us to actually answer questions on dedicated solvers and what they do and why they do certain things and so on, because that would be kind of exponentially many variables to optimize with exponentially many constraints. Okay? So thank you very much.